Thank you for giving me also a great opportunity to introduce our work. My title is that the human robotics, like that the last talk and Professor Rodet gave us that great book of the human robotics, but also like in
Sorry
2006.
to interrupt. I think your slide is not full screen.
Oh, really?
Oh yeah, Kenji. So if you can, we can see 2 slides basically. So
Oh, really? About that? Wait. So maybe I can change that. So like this.
yes, that's
Perfect.
right.
This will be okay.
Yeah, perfect.
Okay. Sorry. That okay. So this Suguru Ali Motors also said that, but both are that the some of overlapping. Of course, that the lack of knowledge of everyday physics and the sophisticated interplays with the environment. So also in the human side, of course, that understanding of this biomechanics or that the neuromechanical controls, and those are the human robotics field. So I am trying to tackle with the problem of that what are the function of embodied intelligence with cyborg type of robot. So what we are working on this kind of exoskeleton robot for the patient with stroke, spinal cord injury, especially with the lower limbs and the whole body's movement. So the issue is that the robotic dynamics and also human sense of agency. Not only this kind of the wearable exoskeletons, but also these kind of prosthetics hand are the one of the issue of the research topic. So can you see the sound? Can you hear the sound?
No,
Oh,
now we can hear.
so this trumpet is like that the plate with that also prosthetics hand, but controlled by that the biosignal. But still, not only full hold that the hand, so human stiffness and dynamics are like integrated with the robotic motions. So these are that the human adaptation and the robotic augmentation. And this time, I am that we have an issue of this the sense of agency, like subjective awareness of initiating, executing, and controlling is kind of an actions. So let me introduce that first, like this the exoskeletons and lower limbs issues and body synergy for reshaping gait functions. So idea is very simple. So upper and the lower limbs do not move separately. So when we work, we use that not only that the lower limbs, but also like the upper limbs movement. So this upper and lower limbs coordination is of course done by the musculoskeletal systems. And then brain trying to give that the signals to control that the limbs. We pick up that the biosignals from the lower limbs and to control that the exoskeleton. So this is that the biosignal-based robotic intervention. But at the same time, sometimes that the hemiplegia patient, those signals are not available. So we can use that some heterotopic control. Are still voluntary movement or not is that the question. So this is an example of the controlling this exoskeleton robot based on that unaffected side of the right legs. So these left legs are controlled by actually that the right legs. But still, rehabilitation trainings works very well, which means that the voluntary-based action control may work under this heterotopic control. Because we have an issue of body synergies. This reshaping that gait coordination is a kind of coherence with body mechanism and motion control are well known that. We have done also many works on that. And then one typical like that the like a particular example is this one. So the Ivanenko's group did that some of that the special research is like that walking with hands. So human gait with a different gravity, putting a treadmill on this kind of strange shape and asking him to walk by hand. But still those kind of that movement lower limb react like the gate patterns. So this means like that this biosignal-based robotic intervention, we can also extend about that. Even if upper limbs triggering control can work with that this kind of heterotopic and voluntary control of exoskeleton. So motor recovery is possible if even upper limb triggers the lower limb's motion. So this is an example of that, the person with spinal cord injury, and the 3 of 4 patients like that increase that the motor activities after the sessions in that the immediate that the effect. So these kind of things is still with that the robotic systems. We are actually trying to understand how that the humans react, how humans adapt. So at that time, the important things is this, that the sense of agency, because many of that the patients said that he or she works by himself. So like this one is still we are struggling to understand about that. Another project is the challenge to remove chair from the wheelchair. So this is also the challenge is toward life with standing mobility unlimited. So we'd like to introduce the standing mobility device. This can help that the stand up and sit down by his own voluntary upper body's motions without using any electrical motors. So this is that the natural postural transition supported by passive dynamics between standing and sitting by voluntary intentions. Because those kind of mechanisms allows us, because it's from sitting to standing and standing to sitting, that the body's movement are different. So like equilibrium point between the machine and the humans we can control, then can realize this kind of like standing and sitting posture, the changes. So this is that some examples of that. So we asked that like many of our that the members, who is older that the person with that the spinal cord injury. We asked that what you want to do that if you can stand up. So going to the supermarket, also washing that the car by himself, and also like that the picking something from that higher place, playing a basketball. So important things is that because very simple movement of even if this one is can move that by using upper limbs that are tilting or going forward and backward. We try to as much as possible helping them like that to move by himself. So like that, many of that the participants they participated in these studies, but the very interesting things is most of that the person said that it can stand and sit down by himself. Of course, that the machine can help that because those are most of that the patient with that the spinal cord injuries. So these kind of like the designs with the passive dynamics is not only this kind of standing device. For example, we can develop like the transfer and dressing for toileting that the independence. So even with that, this mechanism can help them to like that the wearing on and off of the pants, even with that under the support of that robotics. And then this is not simply that the wearable robot, but this is kind of like possibly postural control again for strollers. So just like natural movement, if you can design like this, so which is that we can keep that stability of the sitting postures by using the passive dynamics. So this is the end of my talk, which is what we are trying to do that. This is what a function of that embodied intelligence with a cyborg type of robot. And we would like to know about that, how people adapt to this robotic and passive dynamics. Thank you for your attention.